Hey there. So, this lesson today is really about two different things, okay? It's going to kind of be broken up into two parts. And the first thing we're going to talk about up here in example one is what is the domain of an expression? Okay, well, we're going to talk about domain and what it is and how do you find it. And then the second part of the lesson, we're going to be talking about simplifying rational expressions. This is where, if you remember back to Algebra 1, where you factor the top and bottom and see what cancels out, and you're trying to make the fraction a little more simplified than what it started with. So those are the two things we're talking about. Now I want to come back up to domain and talk about it a little bit. And I know you guys have probably heard this word, usually coupled with range. I think in Algebra 1, here's what would happen, is you were given a set of numbers, and maybe I'm wrong, but I think this is typically what happened. You were given a set of ordered pairs, like 5, 1, 2, -3, 4, 6. I'm going to make these up. And the question that got asked of you is, what is the domain? And if you think back to what they were looking for, domain is just the x values. So the domain would be 5, 2, and 4. Range is the y values. So 1, -3, and 6. Okay, so that is how you learned it back in Algebra 1. Domain is the x values, range is the y values. And that's not all there is to it, but that is a good starting point as far as discussion purposes, okay? Is understanding that domain is the x. Now, as far as expressions go and domain, really what domain is of an expression, if you look at these questions, it says, what is the domain of the expression? What is the domain? What is the domain? What's being asked of you is this. They're really saying, what are you allowed to plug in for x such that when you do the computation, like when you work the expression out, you get a defined number, you get an output, you get a value in the end. So I'll say that again. Domain is what numbers can you plug in for x that when you take your calculator and you go doot, 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 it gives you a number as an answer versus like undefined or can't be done, okay? So domain, we'll define it as the set of x values, set of x values you can plug in that keep the expression defined, meaning it's going to give you an output. Okay, so it's the set of x values. So domain is saying what can you plug in for x that when you do the expression out, you get a value in the end. Okay. So let's talk about how we find that and how we kind of think through this. So I look at example 1a, and it says, what is the domain of the expression the square root of x minus 2? So really saying, what are you allowed to plug in for x? And your first thought might be, well, I could plug 3 in for x, maybe 6, a million. And so it's hard to think in terms of what can you plug in. And so in my opinion, the better way to think about it for square roots is what can't you plug in? What types of numbers can you not take the square root of? And so that's how we have to start this problem. Think to yourself, what types of numbers are you not allowed to square root? That if you square root it, you don't get an actual value. Now you can square root 5, right? Even though 5 is not a perfect square, you could take the square root of 5 and get 2 point dot, 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 whatever. You get an actual number. Think about what you're not allowed to take the square root of. And hopefully your brain goes towards negatives. You cannot square root negatives, okay? So start there. I'm trying to think, what can I plug in for x that I'm allowed to do this computation? You cannot take square roots of negatives. Okay, so really what that means is this expression under the square root, let's think about this. This expression, this x minus 2, it can turn out to be 0. If this turns out to be 0, I can take the square root of 0. Square root of 0 is 0. So this expression can be 0, which means x can be 2. I can plug 2 in for x. And also, I want to keep this positive. So this expression has to be 0 or greater than 0. And there's an inequality that you guys have learned, greater than or equal to. All right, so what we're trying to do is keep this expression under the square root 0 or positive. So we set this expression, x minus 2, greater than or equal to 0. We're trying to think about what x values make this true. Whatever x values make this true is our domain. Well, now we solve this. Add 2 to the other side. x is greater than or equal to 2. Okay? What this means is we're only allowed to plug numbers in greater than or equal to 2. Now, the way we'll write the official domain is this. Okay, here's how we write the official domain. We always start with the phrase all real numbers. Our domain, when it says what is the domain, we're going to say all real numbers. We could plug anything in the world in for x, as long as x is greater than or equal to 2. Now, there is an abbreviation for all real numbers. It's a capital R with like a square bracket coming off the end. So this means the domain is all real numbers. I could plug anything in where x is greater than or equal to 2. That's the domain. So these are all the numbers I could plug in that give me an output, if you will. And so think about that. Like if I would plug 1 in for x, think about what happens. 1 minus 2 is negative 1. I can't square root negative 1. So 1's not in the domain. So it has to start at 2, including 2, and anything greater than 2. Okay? So that's how you do domain with square roots. Try to keep what's under the square root, the radicand, greater than or equal to 0. All right. Second one. What is the domain? Let me make sure this is recording real quick. Yeah, I think it's recording. So B says, what is the domain of this expression? So it's saying, what are you allowed to plug in for x? Well, think about it. What types of numbers can you plug in for x that when you take out your calculator and you do PEMDAS, you get a value in the end? I just want you to think about that. What can you plug in for x there? Can you plug 0 in? Yeah, then this would be 0 plus 0 minus 2. You get negative 2. 0 is fine. Can you plug 100 in? Yeah, you end up getting a big number, but yeah. Can you plug negative 1 trillion in for x? Can you do negative 1 trillion cubed times 2 plus 3 times a trillion minus 2? Yeah. So is there anything you're not allowed to plug in for x? No. You could plug anything in the world in for these x's here, use your calculator, and get a value out. So think about what that means about the domain. What are you allowed to plug in for x? Well, anything in the world. So the domain is all real numbers. Any polynomial, so when there's not a square root or there's not a fraction, any polynomial, the domain's always going to be all real numbers. You can always plug anything in. All right, C, what is the domain of this expression? So now we need to treat this one a little different than the square root. And so here's the deal. Where there's going to be conditions, if you will, like numbers you're not allowed to plug in, that's only going to happen if you have square root expressions or fraction equations. This is where you're going to have things to think about, okay? With square roots, you're trying to keep the radicand greater than or equal to 0. So you just set what's underneath it greater than or equal to 0 and solve it. Fractions are a little different. I want you to think about in math what you're not allowed to divide by. We've talked about it a little bit in this class. What are you not allowed to divide by? Well, hopefully your mind thinks 0. You can't divide by 0. So I can plug anything in the world in for these x's here. I can plug 10 in for these x's. I get 10 plus 2 divided by 10 minus 3. I'm going to get a number. All right, doesn't matter how weird it is, I get a number. I could plug 0 in for these x's. 0 plus 2 is 2. 0 minus 3 is negative 3. And so I get 2 over negative 3. I get a number. Think about the only thing you're not allowed to plug in for x. What can't you divide by? Well, you can't divide by 0. So you have to think to yourself, what would make this denominator 0? Whatever makes this denominator 0 is excluded from the domain. That's what x can't be. Well, 3 makes this denominator 0. If I plug 3 in for these x's, I get 3 minus 3 in the denominator. I would be dividing by 0. Can't be done. So I can plug any number in the world in for x except 3. I could plug negative 2 in for x. You can have 0 in the numerator. You're allowed to have 0 divided by something, but you can't have 0 on bottom. So the only thing I can't plug in is 3. So my domain, I would say all real numbers where x does not equal 3. It could be anything else in the world. If I plug anything else in the world in, I get a value except 3. So there's really, with domain, 2 things to think about. With square roots, you set your radicand greater than or equal to 0, solve it, and that really tells you what the domain is, what x is allowed to be. For fractions, you're trying to think what makes the denominator 0. Whatever makes the denominator 0 is what x is not allowed to be. It could be anything else except whatever makes the bottom 0. So that's domain. It's what are you allowed to plug in for x that gives you a real number value. All right. Moving on to the second part of the lesson. It says simplify and state any restrictions. Okay. Simplify and state any restrictions. Here's what I want to say about simplifying. You cannot go into a problem looking to cancel things out. What I mean by that is I can't look at this and be like, oh, I remember I can just take 12 and 6 and just reduce it to 2 and 1. Or jumping down here, I can't say, oh, there's an x squared here and an x squared here. I can just cross those out. You're not allowed to cancel out terms, like things that are being added or subtracted, but you can cancel out common factors, things that are being multiplied to everything else in the numerator or denominator. So when you go into simplifying, you're going into it thinking in terms of factoring, okay? So we are going to factor, in this case, the numerator. I want to find what multiplies, for this one, what multiplies to negative 12 and adds up to 4. And you get, well, we need to be good at this, but positive 6 and negative 2. So when I factor this, I get x plus 6, x minus 2 on top. I go to the bottom and I factor it. Well, I can pull 3 out. X minus 2. The x minus 2's cancel. And so your simplified is x plus 6 over 3. You're done. That is it. You cannot divide the 6 and 3 here and reduce that because of that plus sign right there. So you can't simplify or cancel terms. It has to be a factor, meaning the reason I can cancel this whole x minus 2 is because it's being multiplied. This x minus 2 on top is being multiplied to everything else up here. This x minus 2 is being multiplied to everything else on bottom. That's why I can cancel it out. But I cannot cancel the 6 over 3. Now the restriction part. Okay, so the simplifying part is one step. The state any restrictions is a second step. Here's how you go about restrictions, okay? Just like this one up here when we were talking about domain, we were thinking about what can't you plug in for x, what makes the denominator 0. We're going to do that same thing with rational expressions, with fraction expressions. You need to go back to the original expression. Here's the tricky part of these. You want to look at what's going to make the denominator 0. Okay, so where you need to look for your restrictions is right here at the factored part of the denominator. This is where you're going to look for your restrictions. And you have to look at any factor that has an x in it. So this 3, for restrictions, this 3 doesn't mean anything. We want to look right here and think, what's going to make this equal 0? Whatever is going to make this equal 0, x can't be that, because you can't divide by 0. So think about what makes x minus 2 become 0. And hopefully you got 2. So here's the thing. This fraction equals x plus 6 over 3, but, we put a comma here, but x cannot equal 2. X could be anything in the world except 2, because if I would plug 2 into this expression, I would get 0 in the denominator, and it would be undefined. So for your restrictions, you're looking at the denominator. You're trying to think what makes the original denominator 0. So you go to your factored part of the denominator. That's my advice. And even if something cancels, okay, so really you could state restrictions before you cancel out. Those are like two completely separate parts of the problem. And maybe we'll do that in the next one. But your restrictions are whatever are going to make the denominator 0. The numerator does not matter, only the denominator. Let's look at example 3. Simplify and state restrictions. So we cannot go into it looking to cancel. You can't. You'll run into issues and trouble. Go into it looking to factor. So I look at the top, and I notice I can take an x out. Always look for GCF first. I can factor an x out. So I'm going to do that. I'm going to take an x out of the numerator. So you get x squared minus 4. And in the denominator, let's find what multiplies to negative 2 and adds up to positive 1. Negative 2 and positive 1. So that would be x plus 2, x minus 1. Positive 2 and negative 1. If I multiply them, I get negative 2. If I add them, I get positive 1. But I'm not done factoring in the numerator. I'm not done factoring that. This becomes x plus 2, x minus 2. So I get x plus 2, x minus 2. And then on bottom, I get x plus 2, x minus 1. So factor as much as you can. If you want to state your restrictions now, that could be a good idea. We care about what makes your denominators 0. We care about what makes the denominator 0. Well, x can't be negative 2, and x can't be positive 1. Negative 2 would make this 0. Positive 1 would make this 0. So you can state your restrictions now if you wanted to. X cannot equal negative 2 and positive 1. Those are the restrictions. Let's cancel the x plus 2. So what is left, you don't have to multiply it out. It's not wrong to. But if you just want to just write the factors that are left over, I'm fine with that. Meaning x times x minus 2 on top, x minus 1 on bottom. That is the simplified fraction right here. Here are the restrictions. X cannot equal negative 2 or 1. So factor, 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 then cancel. Okay. All right. 4. 4. So we go into it, and we're not going to go into it looking to cancel. I wouldn't say, oh, divide the 12 and the 4 and get 3 over 1. You might want to, if I were you, and if I was sitting there watching this, I would pause this and try this one on your own. You're going to learn so much more in this class by doing things on your own and being wrong and learning why than me just saying, here's how you do it. So I would encourage you to push pause right now and just try it. Okay? You have an eraser. If you're wrong, that's fine. Just try it. Push pause, try it. Okay, let's see if you did it right. So on top here, I noticed that there's something other than 1 in front of x squared. And that stinks, because this whole method of finding two numbers that multiply to c and add to b only work if there's a 1 in front of x squared. There's a negative 1 here. Well, there's something we can do. Here's a little trick. I'm going to pull a negative 1 out of the numerator. You'll see why. And that's going to flip all the signs that are left. So now I'm going to have positive x squared, negative x, negative 12. So I've created a positive 1 in front of x squared. I'm going to be able to factor this thing here that's left over, just like I did the other ones where you find your two numbers. On bottom. Now everyone has their own methods of factoring when there's a number in front of x squared. You could do the AC method. You could do guess and check. I like guess and check, but I'll go through the AC method here since I know some people are a little uncomfortable with it. So here's what I do. I'm going to do this work off to the side. I'm going to multiply 2 and 4 together. I get 8. I'm going to find a pair of numbers that if I multiply them, I get 8. If I add them, I get negative 9. So negative 1 and 8. Or negative 1 and negative 8, sorry. Negative 1 and negative 8. If I multiply them, I get 8. If I add them, I get negative 9. I'm going to take the original expression and split up the middle term. So 2x squared. And I split it up into these two numbers I just found. So negative 1x, negative 8x, plus 4. Now that I have 4 terms, I'm going to factor by grouping. I'm going to group the first two, group the second two. Here's where you need to be careful. We probably talked about this last class. This is before we were going over the factoring homework, but hopefully this came up. If there's a minus between your groups, that flips this sign. You have to manually change the sign in the second set of parentheses. You need the signs in the parentheses to match. So if there's a minus between your groups, that makes it a minus 4. So now let's take the GCF of each group. Let's take an x out. So you're left with 2x minus 1. Minus, take a 4 out, 2x minus 1. And now that they each have a 2x minus 1, that goes in one set of parentheses. And in the other set, you have an x minus 4. And there you go. So multiply a and c, split up your middle term, factor by grouping. I'm not done factoring the top, though. On top, I can find what multiplies to negative 12 and adds up to negative 1. So negative 1, let's see. Negative 4 and positive 3. If I multiply negative 4 and 3, I get negative 12. If I add them, I get negative 1. So x minus 4, x plus 3. Right there. The x minus 4's cancel. So we get negative 1 times x plus 3 on top. And on bottom, you get 2x minus 1. Here's the simplified fraction. So factor, 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 then cancel, write your answer. It says and state restrictions. So we put but, okay. Well, we go back right here or here. You look at the factored form of the denominator. It's whatever makes the denominator 0. So you have to ask yourself, what's going to make each set of parentheses equal 0? Well, it's pretty obvious to see this one is 4. X cannot be 4 from this right here. 4 minus 4 is 0. It's a little tougher to see what's going to make this equal 0. So here's my advice. Anytime you're trying to think, what can you plug in for x that makes this equal 0? Well, set it equal to 0 and find out. You're allowed to do that. Set it equal to 0 and find out. So set 2x minus 1 equal to 0, solve that, and that tells you what makes 2x minus 1 equal 0. So add 1 to the other side and divide by 2. X equals 1/2. 1/2 makes this equal 0. So going back to your restrictions, x cannot equal positive 4 or 1/2. All right. Multiplying and dividing are much of the same. It's just more of it. So with these fractions, you just factored the top and bottom and then canceled. With multiplication, now you just have 4 things to factor. Factor the top left, top right, bottom right. And then any factor on top can cancel with any factor on bottom. And you'll see that show up here. All right, so I'm going to factor. So when I factor 2x squared plus x minus 6, you can use the AC method or slip, slide, divide, whatever you want to use. I'm going to do guess and check, since I did the AC on the last one. I know that the first terms have to be 2x and 1x. I know that because when I multiply those together, I have to get 2x squared. So I know that has to be 2x and 1x. The last terms are where the tricky part comes in. I need my last 2 numbers to multiply to be negative 6. So either like positive 1 here, negative 6 here, or say positive 3 here, negative 2 here. So I need them to add up and multiply to be negative 6. The hard part is, think about if you FOIL your thing out. Your inner terms and outer terms have to add up to positive 1. So that's the harder goal to meet. That's why it's called guess and check. Like you plug a couple numbers in, see if it works. So I'm going to just start with positive 2 and negative 3. So if I would put positive 2 here, just think about this, and negative 3 here. Well, my inner terms would be positive 2x. My outer terms would be negative 6x. Positive 2x and negative 6x don't add up to 1x. So that's not right. What about positive 3 and negative 2? What if I put positive 3 here and negative 2 here? Well, then I'm going to have positive 3x and negative 4x, and positive 3x and negative 4x is negative 1x. That's not right, but it's close. So maybe this has to be a negative 3 and a positive 2. Now let's see. That would be negative 6 on the end. In the middle, I get negative 3x. The outer terms give me positive 4x. Positive 4x and negative 3x give me positive 1x. I factored it. Some people like that method because they can find their numbers really quick. Some people can't, or you struggle with signs. Don't do it. Do the AC method or whatever you've learned, but that's an option. On bottom here, I can find what multiplies to negative 5 and adds up to 4. So x plus 5, x minus 1. Anytime I factor something, I usually cross it out. Because you're really done with that expression, you factored it. Bottom right here, I can pull out a 2x GCF. Always look for GCF. And I'm left with 2x minus 3. Top right, well, I can they all have an x in it, so I can factor an x out. And you're left with x squared minus 3x plus 2. Which then can factor more. I can find what multiplies to 2 and adds up to negative 3. That'd be negative 2 and negative 1. So that's going to be x, and it's getting kind of hard to write. I should have wrote this over here. I guess I still will. So this becomes x, and then x minus 2, x minus 1. So I have factored. Now, anything on top, any factor I see on top can cancel with any factor on bottom. They don't have to be diagonal. They don't have to be on top of each other. Any factor in the numerator can cancel with any factor in the denominator. So I see, this is the fun part. The 2x minus 3's cancel. X minus 1's go away. I even see an x here and an x here. Those are factors. This x is being multiplied to everything up here, and same with this. So the x goes away. So on top, you're left with x plus 2, x minus 2. Make sure you put them in parentheses. And on bottom, you're left with a 2 and an x plus 5. So 2 times x plus 5. There's your simplified fraction. Let's state restrictions. So the restrictions. You look at all of your factors in the denominator before you canceled. So this one, this one, this one, this one, any factor with an x in it, and think about what makes it equal to 0. Negative 5 makes this 0. Positive 1 makes this 0. 0 makes this one 0. 2 times 0 is 0. And this one, a little tougher to see through. So if you can't think, what can you multiply by 2 and subtract 3 and get 0? If you can't look at that and know, set that equal to 0, solve it, and find out. Add 3, divide by 2. So 3 halves. Make that one 0. So the 4 we said, x cannot equal negative 5, positive 1, 0, 3 halves. Those are my restrictions. It's whatever makes any of your denominators 0. So before you cancel. Last one. Division is the same as multiplication, but it creates one step at the beginning. So think about this. You never divide by fractions, right? Think about going back to like 6th grade. You never divide by fractions. You multiply by the reciprocal. So what I do, and this is a little sloppy, if you're a little neater and organized, you might want to just rewrite the problem. But what I do is I want to change this to be multiplication. I want to multiply, so I put a big dot over the division sign, multiply, and flip the second fraction. So the x cubed plus 8 goes up. The x squared plus 2x plus 4 goes down. So now it's the same as example 5. You change it to multiplying by the reciprocal. Notice a little asterisk here. State restrictions after you change to multiplication. Meaning right here, we're going to be stating our restrictions from this right here, after we've changed it. So now it's a complete multiplication problem. We got to factor the tops and bottoms, factor everything that can. So this is a difference of cubes. This is a sum of cubes. So we have to know how to factor sum and difference of cubes. So we take the cube root of each, so x and 2, x minus 2, x squared, square the first, sign changes, take the product of x and 2, square the second. There is the factorization of x cubed minus 8. X cubed plus 8 is the same, except those first two signs will change. So it'll be x plus 2, x squared minus 2x plus 4. So it's the same factoring, but the first two signs will change. Bottom left is a difference of squares, so x plus 2x minus 2. This one is interesting. Let's find what multiplies to 4 and adds up to 2. You got 1 and 4, that doesn't add up to 2. You got 2 and 2, that doesn't add up to 2. This just can't be factored. Can't be done. All right, so now any factor on top, let's cancel with any factor on bottom. I notice an x minus 2. I see an x plus 2. Even this trinomial goes out, which is really nice. And essentially, this is in parentheses. And so you can cancel that entire trinomial. He gone. So the only thing that's left, if I'm scanning this, is this trinomial on top. X squared minus 2x plus 4. State restrictions. All right, state restrictions, comma, but x cannot equal. Let's think about what's going to make our denominators 0. Negative 2 will make this 0. X can't be negative 2. Positive 2 makes this 0. X can't be positive 2. Negative 2 and positive 2, if you want to write that as plus or minus 2, that's fine. This is where it gets interesting. What's going to make this equal 0? It doesn't factor. But just because it doesn't factor doesn't mean you can't solve this. I said up here, if you want to know what's going to make something equal 0, set it equal to 0 and find out. Set this equal to 0. You all learned a formula that will solve any quadratic equation in the world. You've all learned it. It's the quadratic formula. The song is probably running through some of your heads right now. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. We can use this to solve this equation to see if there are any more restrictions. X equals negative b plus or minus square root of b squared minus 4ac all over 2a. Let's do it. Remember, a, b, and c are just the numbers in front of your terms. A is 1, b is 2, c is 4. So negative 2 plus or minus the square root of b squared, so 2 squared is 4, minus 4 times a times c, all over 2a. Again, we are solving to see if there are any more restrictions. Are there any more x values that make this become 0? That's what we're looking for. So we get negative 2 plus or minus the square root of. This becomes 4 minus 16. So negative 12 over 2. At this point, we would take the square root of negative 12. But we talked about up here with domain, you can't take square roots of negatives. You don't get real numbers. What this means is there are no real numbers I could plug in for these x's here that would make this equal 0. Which is a good thing for you because that doesn't create any more restrictions. This just means there are no more restrictions. You can't do this. So we're done right here. Now you didn't know that. You had to go through the quadratic formula to see that. But just because something doesn't factor doesn't mean you can't solve it. You can use the quadratic formula right there. All right, so real quick recap. Domain is what are you allowed to plug in for x that keeps your expression defined. With radicals, set your radicand greater than or equal to 0. With fractions, figure out what's going to make the denominator 0. X can't be that. It can be anything else except that. The other ones, it's just all about your knowledge of factoring. Factor, 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 and cancel. Your restrictions are what make the original denominator 0. So look for right after you factor. It's whatever makes those factors equal 0, those are your restrictions. Even if something cancels, the numerator is irrelevant. While you're working through the homework, make sure you guys are asking me questions. Peace!